Hi everyone, I'm Saaransh Shrivastava and this is the Minute Mentor. Today I'm going to be covering the first chapter of physics, which is motion. Let's get right into it. Now see, I want to clear all the doubts. First, physics is not about memorizing definitions. It's basically how we see the universe in all its aspects. So today I'm going to teach you the same, and I'm going to teach you in very much depth and with a lot of resources and various examples. So stay tuned and watch till the end. Okay, the first concept, which is motion. So, motion is relative, right? Yeah, so let's take a little example of that. Now, look at this train here. You're standing on the ground, and for you, the train is moving at 100 kilometers per hour, right? Yeah, that's simple. But wait, let's teleport you inside the train. Now, look at the train. It looks like it's not moving at all. But on the outside, the trees are moving backwards at a minus 100 kilometers per hour. So, is the train moving or is it not? It depends on actually who is watching. There's no absolute motion or absolute rest. It's all about your reference point. Now, let's clear up the next big confusion, which is if you leave your house and you go to school, we travel some length. Yeah, and that is distance. So, if you go to the park next, your odometer or the distance keeps counting up. Distance is just scalar, right? So it just adds up. But it doesn't care about the direction, does it? No, that's vector. When you're traveling some distance and the direction matters, then that's a vector quantity. And one very good example of vector quantity is displacement. So when you come back home, you actually traveled 0 meters as per displacement. You can see that in the red box right there. But why? Because as I said, displacement is a vector quantity. It cares about where you started and where you ended, nothing else. And it cares a lot about the direction, unlike distance. So in the eyes of physics, you actually moved nowhere. Now, what is the difference between uniform and non-uniform motion? That's a big problem there in students, and I'm going to clear it all up. Now, watch at this blue car. It covers equal distance in equal intervals of time, and it's smooth, and that is uniform motion. But this red car, it starts slow, but then zooms past the blue car, and its velocity is continuously changing. That is non-uniform motion or acceleration. Okay, now it's time for the tricky part, a little math. There are 3 equations that actually governs all rules of motion. V is equal to U plus AT, S is equal to UT plus half AT square, and V square minus U square is equal to 2AS. Just don't memorize them, visualize it. Look at this graph here. If I set the acceleration to 5, watch how quickly it goes from here to there and how it climbs up. The equations just predict the future position of the car. Just plug in the numbers and enjoy your show. Now, graphs scare a lot of people, and I too was scared a lot by graphs. But actually, it's just a form of stories. Now, look at this green graph here, the distance time graph. When I walk slowly, the line goes up steadily, and that slope is just basically my speed. Now I run, and see how the line gets steeper? So that means steeper slope has a higher speed. And when I stop, the line goes completely flat. So as time moves on, the distance doesn't change. So I'm at rest. Now let's conquer the final boss. Uniform circular motion. What is that? So it's basically, and when an object is moving at a constant speed 10 meters per second, is the velocity constant? No. So what is uniform there? The speed is uniform, but the velocity is continuously changing. Why? Look at this green arrow here. It's changing its direction, and velocity is a vector quantity. So it's basically speed plus direction. So if the direction changes, then the velocity is actually just changing. And because velocity is changing, there must be an acceleration. That arrow which is pulling it inward is centripetal force. And without that, the ball will just fly off in a straight line. So that centripetal force is pulling it inward and keeping the ball in uniform circular motion. And that's all. And this is the entire chapter of motion. We covered reference points, vectors, acceleration, graphs, and circular motion. And if you want to master physics, we just don't have to read it. We have to visualize it. I was Saaransh Shrivastava, and this is the Minute Mentor. Subscribe for chapter 2.